ನರೇಂದ್ರ ಮೋದಿ ಕಾಲ್ ಮಾಡ್ಬೇಕು. ನಮ್ಗೆ ಅಬ್ಸರ್ವೇಷನ್ ಕೊಡು, ನಾನು ಎದ್ದೋಗ್ತೀನಿ. ನಾನು ಅಬ್ಸರ್ವೇಷನ್ ಕೊಡೋದು ನಾನು ಹೋಗಕ್ಕಾಗಲ್ಲ. ಎರಡು ಒಂದೇ, ಬಾಯ್. ಲೈಟ್ ಯಾಕೆ ಆಫ್ ಮಾಡ್ತಿದ್ಯಾ? ಹೌದು, ಆಫ್ ಆಗ್ತಿತ್ತದ ಮತ್ತೆ. ನಿಂಗೆ ಅಷ್ಟೇ, ನಿಂಗೆ ಅಷ್ಟೇ. ಅದಕ್ಕೆ ನಾ ಏನ್ ಮಾಡ್ಲಿ? ನಾ ಏನ್ ಮಾಡ್ಲಿ? ನಾ ಏನ್ ಮಾಡ್ಲಿ?
Yeah, hi guys. Good evening. I hope I am audible to everyone. Yeah, thank you. We'll start in a couple of minutes. Yeah, good evening, Praveen. Yeah. So good evening. I hope my screen is visible. I've started my screen sharing. So yesterday we started this workshop and today is the day two and the last day. So as per our plan, yesterday we are done with the discussion on understanding what is AI, what is machine learning, and what is deep learning. Then we have also seen how to build a machine learning model from the scratch. Okay. Just a minute. Yeah. Okay. So we are done with this part in yesterday's session. Now today, let us explore a very, very important one, large language models. Okay. So yesterday we understand what is a model and all. Now today we will see what is language model and what is large language model usually. Okay. Then finally, we will try to build an applications using LLMs. Okay. We'll try to use various LLMs like Google Gemini. So different LLMs we'll use and we will make applications and just we will check it out. Okay. So we'll explore these two and that will conclude our workshop. Okay. So as I told you yesterday, so as usual, whatever the notes that I'm going to write today, like yesterday, I'll be sharing it. Then those who are present for these 2 days, then automatically you will be receiving so certificate participation certificate and 2 days participation is very much essential. Now next one is like today also we're going to give you a small task maybe at the second half of the session. Okay, then the detailed roadmap to GenAI. So what are the things that need to be explored? So that is what you will learn in today's session. Okay. Then yesterday we started our discussion with foundations of AI, right? So we understand what is the advantage of making machine intelligent. Then we started like we learned how to make the machine intelligent, right? So the answer is like you have to train the machine. So what are the requirements to train the machine? You need the data, you need algorithms, right? So whenever you load data and algorithms to your machine, then outcome of that machine learning is called as model. Then we understand what is machine learning and we define machine learning as it's a process of training a machine with the data and algorithm. Then now coming to data, there could be sometimes complex data also. Now conventional machine learning algorithms cannot detect the patterns from the complex data. So that's the reason instead of using the conventional algorithms, we'll use ANN, artificial neural networks based algorithms. And wherever if you use ANNs, that comes under what? Deep learning. Okay, such type of models, we call them as the deep learning models, right? Similarly, now coming to so deep learning, what is nothing but it is nothing but the process of training machine with complex data and with ANN based algorithms. Now, what is complex data? Either it could be image or it could be the text data, right? So fundamentally, deep learning you can see into two domains. Like one is the domain which works with the images. Okay. Then similarly, the second one is the domain another which works with the text data. So the domain which works with the images that we call it as a computer vision, and the domain which works with the text data that is called as a natural language processing. Okay. Then finally, convolutional neural networks will use in computer vision. Recurrent neural networks will use in natural language processing. And okay, so if you want to train the machine, you should be perfect in machine learning. Then you can start learning, working on the deep learning. Then if you are good enough in the NLP, then you will directly connect. You can connect into LLMs. Okay. So if you want to create a ML model from the scratch, Now, what are the steps that I have detailed in detail? I have explained yesterday, and these are the things that we have discussed in yesterday's session. Okay. So now today, day 2, let me put, okay. So what are day 2, DAY, day 2? Okay. So today we're going to discuss about the very, very important topic called as LLMs. Okay. LLM, which stands for large language model. Okay. Then let us work on building applications using. Okay. So let us build how to call these large language models and how to build applications. Okay. Using LLMs. Okay. So we'll try to understand the complete, backend part of this large language models. Okay. So now let me explain you what is LLM. Okay. What is the large language model, right? So now here, already we know the model, right? What is model? Model is nothing but outcome of the machine learning, right? A model is nothing but outcome of a machine learning. So in general, assume that you have built the model. You have built the model. So in order to build the model, what are the essential things? You know already, right? You need the data. You need the data, right? And in addition to this, you need something called as an algorithm. So I have data with me. Imagine I have a data. Then I have algorithm. Then the outcome will be nothing but the model. Outcome is nothing but your model, right? So now just this is my machine, right? This is my machine, right? So now I'm interested in something called as language model, right? So if it is a generic model, this data could be like, any numerical data or any categorical data, this kind of data it will be, okay? Or a simple text data, or it can be an image data. Now, I'm thinking about a language model. Now, what is a language model? A model that is capable of understanding language. A model which is capable of understanding a language, right? Which language? Human language. Now, what is LLM? What is language model? Language model is nothing but a model that is capable of what? Understanding human language. Understanding human language. Okay. So this is what we call it as language model, right? For example, your ChatGPT. ChatGPT internally uses what? LLM. GPT, generated pre-trained transformer, which is an LLM, right? So now that will be working behind your ChatGPT. So whatever you're asking to your ChatGPT, you can give a question in English. Means you're asking a question in English. Your ChatGPT could be able to give you answer. What it means? It means your ChatGPT could be able to understand human language. English is a human language, right? Now, whatever the language that you'll ask, it would be able to understand it. So, means your machine is capable of understanding human language. So now what type of model is that? Your ChatGPT has internally it is something called as language model. Your Google Gemini AI is nothing but internally it is having like your language model. Okay. Now tell me, if I want to create a language model, now what could be this data, guys? What could be this data? Yes. My question is very simple. I'm asking you, what could be the data? If I want to create a large language model or language model, what could be your data? Right? Input? Yeah, that is input. Obviously, my question is, what is your input data? What do you think? Your text, video? Videos are not required. Information, text. Obviously, it is a text data, right? So now here my input could be entire language. Okay. Entire language in the form of what? Your text. So if you train your machine with the entire data that is available in the language, then your with the help of the algorithm, your machine will detect the pattern in the language. Now, can someone tell me what do you mean by understanding the language? What do you mean by understanding the language? For example, if I ask you a question, okay, let me take an example here. If I ask you a question, what is your name? Okay. Now, see, if I ask this question to you, you will answer this question, right? So what could be your answer? Let me say that. So my name is, let me say, Innomatics. Innomatics, let me say, research labs. Okay, this is what my answer. Now tell me, if you can understand this question and answer, trust me, you will get the intuition to build your LLMs. Now tell me, yes, I can answer this question. When I can answer this question? I can answer this question if I could be able to understand each and every word, right? First of all, I need to understand each and every word. We could be able to understand each and every word, right? We could be able to understand each and every word. Now, I should know what is the meaning of what is the meaning of is, what is the meaning of your, what is the meaning of name. Now, if I can understand each and every word meaning, then with the help of that, I can understand what is the meaning of this entire sentence, the question. Now, if I could be able to understand the meaning of the question, then I can reply back. Then I can reply back. Imagine you don't know the meaning of the words. You don't know the meaning of the words. Now, can you accurately answer the question? You cannot, right? That means if you can understand the meaning of, if you cannot understand the meaning of each and every word, you cannot reply back. That is what the thing, right? So the funda is that if if the meaning of if the meaning of a word should be known, it should be known to understand, to understand, to understand the meaning of the question. The meaning of the question that is asked. Right? If you cannot understand this meaning, if you cannot understand this meaning, then ultimately you cannot reply back. That is the issue. Now, for example, if you ask a similar kind of question to ChatGPT, now ChatGPT could be able to reply because that means your ChatGPT could be able to understand the meaning of entire prompt, entire input text that you are entering. Now, entire input it could be able to understand means what? It could be able to understand each and every word meaning. If you are entering multiple sentences, it could be able to understand the meaning of every sentence, and altogether, it could be able to understand the entire meaning of the context. Right? So just imagine, I yesterday told you, like, it is AI is nothing but replica. I'm coming to Vignesh. Yeah, okay. Just I started my explanation. So you have to be little patient. What if two words are having same meaning, or maybe a single word has two different meanings, right? Right. So I'm talking about, the thing. Okay. Yeah. Srija, let me answer your question at the end. Okay. Yeah. Fine. Right. So now the question here is, just imagine your AI. What is AI? Yesterday we defined that. What is AI? It is nothing but copy of, it's a copy of human intelligence. It's a copy of human intelligence. Right? Now, how this human intelligent process the text data. When I say text data, it can be text, or it can be speech, or it can be your voice, whatever it is. Right? If you can understand how your brain, human brain, handles the text data. Similarly, we can copy the same type of intelligence and we can create a model. Such type of models, we call them as what? Language models, because now you are trying to copy the same thing, your human brain, right? In human brain, there is something called as, if you take human brain, in the human brain, there is something called as, linguistic cortex. Okay? In the human brain, there is something called as a linguistic cortex, right? So this linguistic cortex will help you to understand the meaning of the text data, the meaning of the sentences, whatever the other people are mentioning. Okay. So this is entirely responsible to process what? Your language. Whatever you can hear, you can process. Okay. So what is this? Your human brain. One portion of your human brain I am talking about. Your brain has multiple cortexes. In that, one thing is nothing but linguistic cortex. Now, what this linguistic cortex will do? This linguistic cortex is responsible. It is responsible, okay, to understand. It is responsible to understand and reply. So whatever the opposite person is asking now, so your brain should be able to understand it because of what? Linguistic cortex. Okay. Now just I will show you what is this linguistic cortex and how it goes on. So just try to understand this. Okay. So let me open Google. Now I will say that it is linguistic cortex. Okay. If you see here, okay, I want to go through with this one. If you see this figure or diagram, whatever you may call, you see this. Okay, what is this, guys? This is nothing but entire linguistic cortex. Okay, you see, your sensors are your ears. Language that you hear, whatever. For example, just imagine I'm asking a question to you. Now you will hear. Who is responsible for that? Your inner ear. Okay, and behind it there is something called as auditory nerve, right? And behind it there is something called as auditory pathway that will take whatever the sound that you have heard to your brain. Right now that will be entering into a vernix area. Okay, then that vernix area will process and further it will reach to Broca area, right? And finally, this will generate the response and you will speak out and you will give the response. Okay. So this portion of your brain, we call it as linguistic cortex. Okay. There is something called as linguistic cortex. So specifically, this is auditory cortex and this entire thing we call it as linguistic cortex because whatever the language that you hear, that could be able to understand and you could be able to, reply back. That will happen if you can understand the meaning of whatever the things that have been done, right? So now, my dears, here the very, very important thing is we need to copy the functionality of each and every block that is appeared in the linguistic cortex of your human brain. Okay, that will be appear in the linguistic cortex of the human brain. Okay, so the question is, we are thinking about to build a model like that. We want to create an AI application that can process the human language. That means what? You need to create the copy of your linguistic cortex. Okay, so fundamentally, what your linguistic cortex does. Let me come back here. Okay, so let me come back. Now I want to show what exactly your linguistic cortex is doing. Okay, so for example, these are all the functional layers of the linguistic cortex. So first layer in your linguistic cortex is phonological layer. Phonological layer. Phonological layer, what it does? It will decode the sound. For example, if I ask you the same question, what is your name? Now, when I say what, the moment I ask you what WHAT, your mind, your brain will senses that, okay, what is nothing but it's a word which consists of a spelling. That means word by word decoding is done, right? So it is decoding like, what is your name? The moment I ask the same question to you, if I ask you how many words are there in the sentences, what is your answer? Your answer will be 4 because this phonological layer is doing the task. It is decoding the sound that you have heard. Now tell me, what type of data is this? Now this is a text data, right? This is a text data. Now once the sound is decoded, the sound that is decoded. Now next level what? There is this decoded data will pass to where? Lexical semantic layer. There is one more layer, call it as lexical semantic layer. Now what this lexical semantic layer will do? It will capture the meaning of every word. Okay, what is the meaning of what is the meaning of is, what is the meaning of your, what is the meaning of name, what is the meaning of this question mark? So everything will capture the word level meaning first. It will capture, right? See, this is how your brain functions whenever something is asked to you, right? Whenever, for example, I am speaking this many sentences almost from the past half an hour. So every word meaning, every word I am talking, your brain is decoding it. Okay, then you are thinking about the meaning of every word that I am speaking. Who is responsible for that? The linguistic cortex, which is existing in your brain, that is helping you in understanding. So first it is decoding my sound, then it you could be able to sense each and every word that I am speaking. Then it is allowing you, lexical semantic layer is allowing you to capture the meaning of every word. So means, first of all, you are decoding the sound. From that, you are identifying the words. Then in the next layer, what's happening exactly? The word level meaning is being captured, right? I hope this is clear till this point. Quick yes, no, yes, no. Okay. I hope it is clear, right? Okay. Okay. That's fine. So thank you. Right. Now, once the meaning is captured, once the word level meaning is captured, now what is the next task? The next there will be something called as syntactic layer. Syntactic layer. What this syntactic layer will do? It will make you to understand the grammar and the structure of the sentence or the text data that is being passed, that is being asked. Okay, so you need to understand the grammar and the structure of the entire text data or entire words, entire sentences that have been asked, that you have been heard. Okay, who is responsible for that? The syntactic layer is responsible for that, right? Then once the grammar and structure is captured, now you know the word meaning. Now your brain could be able to identify the grammar and structure of the sentence. After that, there is another layer called as pragmatic layer. Now what this does? It captures the contextual meaning. What is the overall meaning of the text? What is the overall meaning of the question or the sentences that have been asked? Okay, so this is what will happen. Okay, then afterwards, so means once whatever the sound that you have heard, it is passed to the pragmatic layer, you will understand the meaning of this. You see, this process is sequential. It is happening every time, right? Every time you hear a new word, new sentence, new context, ultimately you could be able to understand, right? For example, imagine I am giving my lecture in Chinese language. Do you understand anything? Because you doesn't know, right? You doesn't know that language. You can understand, you doesn't know the alphabets of Chinese. You cannot interpret the meaning of every word. You cannot interpret the meaning of a sentence. You don't know the grammar and structure of your Chinese language. That's the reason if I speak in any other language in which you are not familiar, I cannot understand the context of that sentence or the language. Right? Now, once you understand the meaning, for example, what is the question I have asked you? What is your name? Now you understand the meaning. Now, there is one more layer called as motor articulatory layer. What it does? It will give you speech execution. It will generate the response related to that question. Who is responsible for this? Motor articulatory layer. Okay, so this entire layers are where they are available. They are available in your human brain, and this combination of all these layers we call it as what? Linguistic cortex. So if your linguistic cortex is damaged, then the person cannot understand whatever others are speaking. Okay, if other people does not able to understand the thing means what? Their linguistic cortex is not proper. Now, what your linguistic cortex is doing, it could be able to decode your sound every word by word. Then it could be able to understand the word level meaning. Lexical semantic layer is doing that, right? Then after that, there is something called as syntactic layer, which will identify and verify the grammar of a sentence and structure of the text data, right? Then there is something called as a pragmatic layer that is helping you in understanding what? The context and the intent of the meaning, right? Someone is asking, till now, if the same word has two meanings, or if two words are having similar meaning, now how? Your brain could be able to capture it. If I say that, a lightweight bag is kept in a light room. Now, first light is nothing but indicates the weight of the bag, and the second light is nothing but opposite of the dark. Spelling is same, words are same, but their usage is different. Their context is different. And that different, our human brain is capable of doing it. Right? That is why we can understand, we can interpret, right? Even though sometimes same word is used in a different scenario, same word can be used in a positive way, and the same word also can be used in a negative meaning, right? That human brain is having that capability. Now, what is our objective? We need to replicate the same intelligence so that your machine also is capable of understanding such things. It could be able to handle the entire language, right? Okay. So this is how your human brain functions. This is how human brain process the language that we know, right? I hope everyone it is clear. Quick yes, no, reply me. Any doubts in this? Any doubts in this? All right. So everything it is clear, I hope, right? And this is what will happen in the human brain whenever we speak something, right? So this is how your human brain processes the text data or voice or speech, whatever we are speaking. Who is responsible for this? There is something called as linguistic cortex. Now tell me, what is our objective? Our objective is to make my machine intelligent. Our objective is to build the large language model, right? Now tell me, indirectly what I'm doing? I need to replicate my linguistic cortex. Whatever the linguistic cortex, whatever the task the linguistic cortex is doing, whatever the task the linguistic cortex is doing, right? So now tell me what exactly your linguistic cortex is doing. Step by step, let me put it. First, it is decoding the voice. It is decoding the voice or speech, whatever it is. Now, once everything is decoded, you will be accessing the words, right? In the second layer, what's happening? It is understanding the word level meaning, the meaning of every word that I'm speaking. It could be able to understand individual word meaning. Then afterwards, it is verifying the grammar, okay? The grammar and the structure, whether the sentence is structured properly as per the English grammar or whatever the language that you are speaking. So grammatically it is correct, whether it is structurally correct or not. This is what the same thing is being done. Okay. Now the next thing is, it is also doing something called as contextual meaning. It could be able to understand something called as contextual meaning, right? These are the things that are done by whom? These are the things that are done by your linguistic cortex. Okay, then based on the meaning, it is generating the reply. Based on the meaning, it is generating the reply. And these are all the roles and responsibilities that are done by every layer which is present in human brain. Now, what we need to do? We need to copy the functionality of the linguistic cortex. I need to convert this linguistic cortex into a model. I want to train my machine such that my machine could be able to capture the words automatically. My machine could be able to capture the meaning of the word, and my machine could be able to capture the grammar and structure of the sentence that I am giving in my input. Similarly, my machine could be able to understand the contextual meaning. Okay. See, just now I told you your input could be a language, right? Now, when I say your machine is detecting the patterns in your language means what? Your machine could be able to identify the words. Your machine is able to identify the Word level meaning, your machine understands the grammar of the sentence, your machine could be able to understand the structure of the sentence, and your machine could be able to understand the entire meaning of the context. If these things are done, if your model is capable of doing all these things, now such type of model, we call them as language model. Okay, this is called as what? A language model. Okay, so what is the language model now? The model which is capable of understanding human language, which is capable of process the human language. Such type of models we call them as what? Language models. In simple, LM, right? So this is called as LM. Okay. Now what LM can we do? So let me put it here. Now such type of features, whatever the model. So these type of models, we call them as what? Language models. Language models, which are nothing but copy of what? Your linguistic cortex. Right? Now, tell me, again my question is same. Now, if I want to train my mission to understand every word that is present, the meaning of every word, the grammar of entire language, the structure that is present in a language, at the same time, the entire contextual meaning should be clear, right? So now tell me, what could be my input? I need to give entire language, right? Entire language could be my input. Now, what is the size of this language? Means I have to give my input in the form of a text. Because language, no, if I speak, it will become voice. If I write, it will become text. Now, I need to take it like a text. But how much text? It is, it is large data, large amount of text data. It is large amount of text data. So we are fundamentally building what? A language models. And what type of data we are using? The text data. What is the text data? It is a very large, huge amount of data. So as you are training your machine with a large amount of text data, and you are making your machine to understand the components of the language, that means word level meaning, sentence level meaning, semantics, okay, its structure, grammar, and also the entire contextual meaning. So such type of models, we call them as what? Large language models. Okay, now let me add here large. So now what this word large indicates? This indicates the size of the trained data. So usually whatever the data that you are using to build a machine learning model or maybe a deep learning model, that is not at all sufficient if you want to build a large language model. You need vast amount of data. You know, for example, I can say that there is something called as Google Gemini AI. Okay, there is something called as Google Gemini models, right? Now these Google Gemini models, they uses entire data which is present in your Wikipedia. You know, right? Wikipedia, and you know, everyone, you know, right? How much amount of data is available in Wikipedia? Just imagine how many articles, how many books, okay, how many novels, lot of things, right? You know, it has millions of text documents, right? So this entire data is used to train what? Google Gemini AI model. You just imagine, there are many great organizations across the world, across India. But how many organizations are able to come up with such type of language models or generative AI models? Very few, right? Why? Because that requires the data. Now, Google has data. Google has data, right? So for example, all of us are using Gmail, we are using YouTube. So a lot of every application we are using Google, right? So we are storing entire data in Google. Majority of the applications are Google. Now the Google, they are utilizing that entire language, entire data, and they are training such models, and simply they are giving us like a products. Similarly, another player is whom? Now next one is a Meta, right? So Meta, it owns a lot of things, right? Your WhatsApp, your Facebook, all these things, you know, owned by Meta. So whatever the social media, social networking applications that they have created, you know, because indirectly they are collecting data from you. And this data is being used to train such models. Okay. See, something is coming for free of cost means what? There could be some advantage for them at the other end. Otherwise, why they will take that much effort? Right? So like this, people have came up. So means the point you need to understand is basically these are called as language models. What is language model? A model that is capable of understanding human language. Now, what do you mean by capable of understanding human language? It can understand the words. It can understand the meaning of the words. It can understand the grammar of the language. It can understand the structure of the language, and it can understand the contextual meaning. Right? So this is called as that such type of language models, we call them as language models. And usually if you want to create such language models, usually it requires bulk amount of data. So this large indicates what? The amount of trained data that is required. So that's why these models, we call them as what? Large language models, are in shortcut LLM. This is the story of large language models. Make sense? Right? I hope it is clear, guys. Quick yes, no, yes, no. Okay. Yeah, thank you. Just a second, guys. Yeah, that's fine. Thank you. Now, yeah, that's fine. So my question is, now tell me how to build such type of models. Okay. Now, what type of algorithms that we need to use? Now, again, I'm telling you, if you want to create a model, what type of data is required? You need structured data, and the data should be in the form of a numbers. But what type of data we are using here? It's a large amount of text data, right? So now what is the biggest challenge here? The biggest challenge here. Now, if you want to create LLMs, there are a few challenges. Okay. Now, what are these challenges? Because every model needs every model needs a structured numerical data. Structured numerical data, right? But actually, what type of data you have? Text data, right? This is the first thing. Now the second one is okay, how to convert how to convert such bulk text data into a structured numerical data, into a structured numerical data. Okay. Now, see, we can easily convert it, but what are the challenges? This structured numerical data, from this structured numerical data, you could be able to interpret the words. If I give the text data, you could be able to understand the meaning of the text. You could be able to understand the grammar and structure of the text. You could be able to understand the entire contextual meaning of the text data. Make sense? Okay. So these are the challenges. These are the challenges, right? So now then researchers were started the process in order to convert the text data into structured numerical data. So in order to convert the text data into structured numerical data, we use something called as something called as text vectorization methods. Text vectorization methods. Text vectorization methods. Okay. Now, what are various text vectorization? There are few methods. I'll write few popular methods. There is a method called as bag of words. Now, there is another method called as TF IDF. Okay, so what is TF IDF? Let me write the full name. TF stands for term frequency. IDF stands for inverse document frequency. Okay, so TF stands for term frequency, IDF stands for inverse document frequency. Now, what these two techniques will do? If you provide text data as input, if you provide text data as input, then what you will be getting? You will be getting a structured numerical data. You will be getting a structured numerical data. So this is what they can do, right? It can do bag of words or TF-IDF. These two techniques will convert your text data. If you give text data like which is having n number of words, bulk text data, now you will be getting a data like it will be converted into this, which is a numerical data. Rows and columns, you will be getting it, right? Now, what are the limitations of this? These are very, very old methods. I can say that, these are the first methods when the researchers were, trying to build such models, trying to make machine to understand the language. There are a lot of drawbacks. Let me put like the limitations. Now, what are the limitations of these things? Okay. The limitations are, first thing is, these techniques are simple, but the output data dimensionality is very large. So the dimensionality of output, what is your output? Structured data is very high. That is a problem. What is dimensionality? Number of columns. Dimensionality is nothing but number of columns. So you will get lot of columns, thousands of columns, lakhs of columns. Usually that will become very complex for a model to understand, right? Now the second one is the output. The output is a sparse matrix. It is a sparse matrix. Now, what is sparsity? There are many zeros, right? There are many zeros. So, if you take this such type of data, there are lot of zeros, guys. There are lot of zeros. Okay. So, unnecessarily, it will waste a lot of memory. So, huge amount of memory it will consume in order to store this data. That is the second drawback. Now, the third drawback is it cannot understand the word level meaning. Okay. So, word meaning cannot be interpreted. The word meaning cannot be interpreted. Okay, this word meaning cannot be interpreted. That is a problem. Means you cannot understand the meaning of individual word. Okay, now tell me, if the meaning of individual word cannot be understood, is it possible to understand the context meaning? So the context meaning also cannot be interpreted. The context meaning cannot be interpreted. Okay. The contextual meaning cannot be interpreted. Okay. So now that is the reason these models are not accurate. If you build models based on such type of techniques, no, they are not going to be accurate. See, the purpose is served. If you are giving a text data and they could be able to convert it into structured numerical data, means I can use this data, I can build some models. So what type of models I can build? I can build such simple models like, for example, a simple classification model I can build. A simple classification model I can build. For example, you think that you are getting a lot of emails into your mail, right? So sometimes, the mail may enter in spam. Sometimes it will enter in inbox, actual inbox. So now by default, some of the emails have been entered in the spam folder and important messages will be entered in the actual regular inbox. Now, how it is being categorized? Your Gmail is not verifying every email, right? Your Gmail internally uses the models like such type of models. Now, based on the subject line of the email, it will categorize into whether it will classify whether the email should be a spam or not a spam. So this is called as a spam ham classification problem. So such type of problems can be solved by this TF-IDF or bag of words method up to some extent. Okay, but imagine like ChatGPT, I will ask a question and you cannot expect a reply from such type of models. Simply, it will classify the text like spam or ham. Okay, like document is like, having, I can say that this is a sports document or not. That's it. Whether it is a document related to data science or not. So like that, I can do simple classification task. Okay, but what is our intention? Our intention is not just to build a classification model, right? I need to build a model which can understand the entire language. Whatever I will ask, like ChatGPT, you are getting the answers. Like Google Gemini AI, you could be able to get the response. But with this simple text vectorization methods, I cannot solve my purpose. That is why we are moving to the next level. Okay, guys, I hope I am clear till this point. Yes, no, yes, no. Yeah. Okay. That makes sense. Yeah. Thank you. Okay. All right. Very good. Okay. Huh. So very good. Nice. Now, in order to overcome these drawbacks, we have the next solution. So those methods we call them as word embeddings. We call them as word embedding methods. Okay. Word embedding methods. There are many word embedding methods. Let me mention few names. For example, there is a model called as word to vector. Word to vector. Okay. So now next, there is another model called as glove. Okay. Now there is another model called as fast text. Okay. Now tell me again what these models will do. These models, if you give the raw text data, if I provide the text data, raw text data, now these text data, if I provide the text data, now this data will be converted into structured numerical data, right? That is what I'm thinking, right? That is what my ultimate purpose. So now this can be done for, I can say that your output could be, you can expect like this. Your data will be converted into similar. Now, what is this? It's a structured data, right? Okay. Now, what are this? Those three algorithms are, I can use either word to vec, or I can use glove, or I can use fast text. Clear? So basically, this word to vec algorithm was created by Google. Okay. So this is created by Stanford University students, NLP group. Okay. So this is created by, technique is created by Stanford University. And this fast text was created by popular company called as a Facebook. Now you understand why they are giving all these applications for free of cost, because they are utilizing your data, your entire chart, every message that you are adding, every image that you are uploading. So they are using happily to train the models, right? So ultimately, Now these. Now what are the advantages of using these models? But surprisingly, these models are deep learning models. These are deep learning models. Now, what is deep learning model? You know, right? So which makes use of artificial neural networks based models. So if you want to understand these models, you have to be familiar with artificial neural networks. That's the reason before entering into NLP and generative AI, we at Innomatics Research Lab, first we will explain about the working of artificial neural networks. Okay. And you know how much time we are spending? 2 weeks of time we are spending in understanding the artificial neural networks so that every candidate, every student could be able to understand clearly the upcoming topics like, NLP, RNNs like recurrent neural networks, then convolutional neural networks, all these things, right? Generative AI. So that is why I told you from yesterday, I'm telling you, you cannot directly learn generative AI without having anything. There are a lot of other prerequisites that being a candidate, you have to learn, right? You have to be familiar with the data. You should know little statistics. You have to be familiar with EDA, exploratory data analysis, right? You should know in detail idea about, machine learning model building, right? Then you have to work on like artificial neural networks. Okay, then you could be able to understand word2vec. So without knowing what is ANN, you cannot understand word2vec, you cannot understand Glow, you cannot understand fast text. Okay, so even I need approximately 2 to 4 hours of time just to explain about how to build a word2vector model. So, but for that, in order to understand that, what is required? A clear idea about artificial neural networks is required. So that is why in our Innomatics Research Lab curriculum, we are giving very good weightage to this ANN, and this topic will be discussed for 2 weeks. Okay, so that the next algorithms will be easily you can understand as a student, right? So now tell me, right? Okay, so what are the previous limitations of the previous method? The limitations are dimensionality is the biggest issue, sparsity is another issue, and most importantly, the word level meaning cannot be interpreted. If you cannot understand the meaning of a word, forget about the meaning of the sentence. And if you cannot understand the meaning of every sentence, you cannot understand the meaning of the context. That means you cannot understand your input text data. If you cannot understand what is the user input, then ultimately you cannot generate the response, right? So now, in order to overcome these drawbacks, we came up with this kind of methods like, like word2vector, Glow, and fast text. What is the advantage of these methods? The first thing is that the problem called as sparsity. Okay, so the sparsity problem is overcome. The sparsity now is this problem is overcome. So now the outcome will be not sparse matrix. These are all dense vectors. Now what is dense vector? Dense vector is nothing but, all the values are filled. Previously, what is sparse matrix? If there are majority zeros, such type of matrix we called as sparse matrix. But if there are very few zeros, majority of the entries are filled, that is called as a dense representation. And the output of this word embeddings are dense vectors, not sparse vectors. Okay. Now, second thing is the meaning of the word. The meaning of words can be interpreted. The meaning of the words can be interpreted. Okay. So meaning of word, every word, individual word can be interpreted. This is the biggest, achievement for the researchers. And now after building such type of models like word2vector or Glow or fast text, now people could be able to do some task. For example, there is some task called as, like parts of speech tagging. Parts of speech tagging. Okay, right? Parts of speech tagging, right? In short, it is called as POS tagging. Okay, there is one more such problem called as named entity recognition. Named entity recognition. Okay, this is popularly known as NER. Okay, Similarly, you can create the cluster of the words. Cluster of the words which are having nearest meaning, no, they will become the clusters. Okay, so that is what you can do it. Right now, just I'll tell you what is POS tagging, what is parts of speech tagging. For example, just I have written this, like, so let me say Innomatics is conducting this workshop. Right now, simply my model has multiple words here, right? My data has multiple words, like, there is Innomatics, there is there is conducting, there is this, and there is workshop. Now tell me, what is this Innomatics? This is a noun. This is my noun. Right? Now conducting, this is the verb. So like this, every word is what? Whether there is an article or preposition or adjective, right? So means every word will be properly tagged with the proper parts of speech. This is called as POS tagging. Now tell me, in order to identify the parts of speech, what is required? If you understand the meaning of every word, that is sufficient. Right? Now, how you are interpreting the word meaning? You are interpreting by using the algorithms like Word2Vec or like Glow, like fast text. Now, these three algorithms will help you in interpreting the meaning of every word. So as meaning of the every word is interpreted, what you can do? You can tag them with respect to those parts of speech. And this problem we call it as POS tagging. Now this POS tagging can be successfully implemented using such type of models. Now other one, which is nothing but NER, named entity recognition. Named entity recognition, right? So for example, let me take another example here. Let me say India is my country. Okay. So now here, for example, you take this word called India. Now what is this? This indicates a geographical location. Okay. Now this is what, for example, country. This comes under the list of the countries, right? So this comes under a name of the country, right? So like this, what exactly we are doing? We are assigning a label for each and every word that is present. So what I can say that proper. For example, if there is India is my country, now let me just extend, like, I can say that, president of India is the first person of this country. Okay. Now what basically this indicates, but president, this indicates again a person, right? So like this, this problem we call it as what? Named entity recognition. If there is any place, this algorithm will tell you it is a place, it is a geographical location, it is a person, it is an object, it is a thing. Like that, it could be able to understand what exactly that word representing, whether that word is a place or it is a person, it is anything, like that. Okay. So means such problem we call it as named entity recognition. Now how to solve this named entity recognition? For that, you need to understand each and every word meaning. If you know the word meaning, that is sufficient. Entire sentence meaning is not required, right? If I know the meaning of the word, I can do this. I can apply POS tagging, and also I can apply named entity recognition. Now another one is cluster of words, because as the word meaning is known, now I can identify what are the other words that carry similar meaning. What are the other words that carry similar meaning? And I can group all the words from the input text data. So that is called as a clustering, and this can be also solved if you know the meaning of every word, right? Word level meaning is known. So just by introducing these word embeddings, people have addressed. See, what is the first problem addressed? They simply solve the classification problem. Because a classification problem just needs pattern in the data. It doesn't require any word level meaning, right? Now, after that, what? Once word level meaning could be able to captured, then we could be able to come up with a solution for problem called as POS tagging or something called as named entity recognition, right? So, but now what are the limitations? Let me write it. What are the limitations of these techniques? The limitations of these techniques are we cannot or it cannot interpret interpret contextual meaning. The contextual meaning. What is contextual meaning? Meaning of a context. I can say meaning of a sentence in simple terms. I can understand individual word, right? I can understand what is the meaning of pneumatics, what is the meaning of ease, what is the meaning of conducting, what is the meaning of this, what is the meaning of workshop. But if I ask together, pneumatics is conducting workshop. Now, entire text, I cannot understand it. Individual word meaning is clear, right? That means if you take the diagram of this linguistic cortex, now the decoding is over. We could be able to extract the words, and word level meaning can be interpreted using what? Using your word to vector algorithms. Okay, now what I need to understand? I need to understand the grammar, I need to understand the structure, I need to understand the context. In order to do this, I need something more, because with the help of these methods, like word embedding methods like word to vector or glow or fast text, it is not possible to estimate the context meaning. So now there is something is required. Okay, now before going to know what is that, just let me know. I hope the things are clear, guys. Quick yes, no, quick yes, no. करते रहो है ना। हाँ बस करते रहो, ऐसे करता है। Guys, some unknown persons are posting some other messages. Please ignore those links, okay? Because we cannot trust the external links. You may face security issues also. So if anyone is posted such links, please ignore them. They are time pass people. They are trying to disturb the sessions. Just, okay, don't fall into that trap. Yeah. Okay, I hope this is clear. Now the next thing is, yeah. Now how to understand the contextual meaning? How to understand the contextual meaning? Now the next step is like the next techniques, we call them as contextual embeddings. Okay, contextual embeddings. Now what are these contextual embeddings? Okay, so these contextual embeddings are called as, for example, there is something called as recurrent neural networks. Recurrent neural networks. Okay. Now, the other flavor of recurrent neural networks are, like, we have something called as LSTM. Now, what is this? This is long short term memory. Okay. Then the third one is called as GRU. The full name is gated recurrent units. Okay. So recurrent neural networks are, in short, RNNs. So we have three options here: RNNs, and also you can have something like LSTM. You can have, like, GRUs, right? Just a minute, guys. RNN, recurrent neural networks, followed by LSTM, GRU, right? What are this? These are various flavors of your artificial neural networks. And these will help you in understanding what? Contextual embeddings. Okay, because these are called as sequential networks. Sequential networks. Okay, what is sequential? Ordered, right? Now, text data is an example of a sequential data. For example, if I write a sentence like this, okay? So what is this? What is this? You know, if I interchange any of the words, either this sentence will become meaningless or the sentence may become opposite. The meaning may become opposite. So there should not be change in the sequence of these words. So such type of data we call it as what? Sequential data. And text data is what? This is a sequential data. This is a sequential data. Now, how to understand the sequential data? If you individually understand each and every word meaning, it cannot be interpreted. You have to read all these words together so that you can understand the entire meaning of the context. Now, if you want to read all the sentences together, that is possible by using what? Your recurrent neural networks. Okay? If you want to understand recurrent neural networks, what is required? ANN. You should have understanding about artificial neural networks. That is very much essential, right? So RNN, now advanced version of that RNN is LSTM. Advanced version of that LSTM is what? Your GRU. Okay. Now with by using such type of models like RNNs, LSTMs, or GRUs, what we can do? It will help you in understanding the word meaning. Okay. So what are the pros of this? You can interpret the word meaning and also you can interpret the context meaning. You can also interpret the context meaning because you could be able to read the sequence. You could be able to read the sequence, right? So that's the reason it will allow you to understand the word level meaning and contextual meaning, right? So now our purpose is served, right? Because we are trying to copy what? The linguistic cortex. What linguistic cortex can do? It can decode the words. Yes, our algorithms are capable of identifying the words. Then word level meaning, we could be able to understand structure and grammar because we are able to read the sentence, multiple words. The grammar and structure can be understood and the context also can be understood. That means our purpose is served, right? But here there is a limitation. Now, what is the limitation? The limitations are how many words it could be able to read at a time. Okay. So simply I'm writing number of words it can capture. Okay. Means at a time, whether the model could be able to read 3 words or 4 words or 5 words or 10 words or 100 words. Because a sentence may have 3 words, a sentence may have 300 words also. There is no guarantee, right? That depends upon the type of the text data. We cannot guarantee that every sentence will have this many fixed number of words. Now, imagine my model could be able to read only 3 words continuously. Now, every sentence has 4 words. Now, tell me, such type of model can understand the meaning of every sentence? It cannot. It cannot, right? Even though it will understand partially, but it is not accurate. Now, this problem is called as, so what are the number of words it can read at a time? So this is called as long-term dependency. Long-term dependency. This is called as long-term dependency, right? What is long-term dependency? How long sentence it can be read, your model can understand. For example, for your ChatGPT, you keep on entering some prompt. For example, if you enter some few tens of lines, it will accept. You try to enter few thousands of lines, what it says? This, your tokens are out of, right? It cannot take more than these words. What is the meaning? Means your ChatGPT could not be able to read more than that many terms. And that is what the long-term dependency, maximum words it can read at a time. This property we call it as what? long-term dependency. And this long-term dependency, if you increase it, now this will become more complex. So the limitation is these are very complex and these are very slow. RNNs will solve the problem, but they are very slow, dead slow. The response time is more. It is taking more time to understand, more time to process. Okay. Now the another thing is, for example, if the same word is appeared multiple times with a different meaning. If the same word is appeared multiple times with a different meaning, then how it utters, how it will captures the right meaning, that is very, very important, right? So these types of features are missing in RNNs, LSTMs, and GRUs. So that is why people came up with another technique. Okay, people came up with another technique. Okay, now they came up with the concepts called as decoder and encoders. Okay, now what are these decoders? Encoders are, these are capable of understanding the text data. Capable of understanding the text data. Now decoders are what? They are good in generating the response. In generating the response, generating the output. So later on, see, if you are giving input like a text, we are expecting output is also text data, right? That is what your ChatGPT is doing. Am I correct? So that is the same thing your ChatGPT is doing. You are giving your input as a text data and you are getting output as a text data. Who is generating that output? Decoder is responsible for that output. So such type of models, we call them as sequence to sequence models. Sequence to sequence models. Input is a sequence text data. Output is also a text data. Okay. This is the next version of your RNN, LSTMs and GRU, and your encoder, decoder internally what they consist? Again, they consist either RNN or LSTM or GRU. But again, what is the problem? Simply the processing time is very large, very high, right? At the same time, if same word is appeared with a multiple times with different meanings, now which meaning, how it has to capture that word exactly with the right meanings. Now this problem is overcome by a new mechanism called as attention. Okay, there is a mechanism called as attention. Based on this attention, Google came up with a structure called as transformer. Okay, transformer. I'm not talking about the transformer that is used in electrical engineering. So this is a transformer that is used in your generative AI. Okay, basically what your transformer will do, it helps your machine to understand the text data. Right? Now what your transformer will have, again it will have all these things, RNNs, all these things internally, it will have kind of a neural networks. But it is incorporated with something called as attention mechanism. Okay, transformer with attention mechanism, right? So today you are using something like, this ChatGPT. Now what is this T in ChatGPT? It is a transformer. This T is nothing but a transformer. So these are all transformer based models. So transformers is the starting point of your generative AI. Okay, sir. Now, if you want to really become a good expert in generative AI, if you are expecting a good job in generative AI, so you should know this entire story. You should understand about sequence to sequence models. That means you should know the architecture of encoders, decoders. You will understand the architecture of encoders, decoders. If you are familiar with recurrent neural networks, LSTM and GRU, and if you want to understand the recurrent neural networks, you should understand first of all what are artificial neural networks, If you understand artificial neural networks, then you can understand word to vector, glow, and fast text. Okay. So like this, the subject is connected. So whatever you studied in between your word embeddings until transformer, this comes under your simple NLP. Now this is transformer is a starting point of generative AI. Okay. You're talking about Google Gemini AI, right? So you're also using something like Google Gemini, Google Gemini AI, right? Now, what this Google Gemini AI? It uses another transformer. You know what is the name of the transformer? The name of the transformer that is used is BERT. Okay, bidirectional encoder representation of transformer. There is one more transformer called as T5 transformer, text to text transfer transformer. Text to text transfer transformer. So T5 it is using, that's the reason it is called as, in short, T5 is another transformer. So this transformer has changed. Transformer with attention mechanism is changed the interface of the NLP, and because of these transformers, first application was created by GPT, ChatGPT. Then after that, Google came up with Gemini AI models, and today Anthropic, other players like Mistral AI. So these are the other people, those who are coming up with such kind of models. Okay. Now these transformer will solve all your problems. Okay. So there is no dimensionality issue. You could be able to, means your machine could be able to interpret the meaning of the word. I can simply write word level meaning, word meaning. Okay. Then also this could be able to interpret context meaning, and also it could be able to give solution for your long-term dependency, and the response is very fast. It is very fast. The only problem with RNNs is what? They are very slow. RNN, LSTM, GRU, they are very slow. Now, how to overcome this problem? These problems are usually, overcome by implementing something called as transformer with attention mechanism. Okay. Now, see, this is what we're expecting, right? We are expecting the model will understand the word level meaning. We are expecting the model can capture the context meaning. Your model could be able to capture the structure, grammar, and that we call it as what? Long-term dependency. And this can be done within very less time. And all the properties of your linguistic cortex can be copied by using what? Transformer. So that is why you take any LLM, right? So I'm talking about the LLM. If you talk about the LLM, usually LLM definitely uses a transformer. Other than a transformer, it need some bulk text data, right? It needs to be trained by using very huge text data. Okay. And it requires the training technique. Okay. It needs some kind of technique. Okay. It needs some kind of, I can simply write method, a training method. Okay. So this is nothing but your LLM. Your large language model is a model which is trained using bulk text data, which is using transformer architecture, and which requires a technique, a method to train to understand the data. So multiple techniques have been used, multiple I'll write what are the few methods that can be used in training the LLMs. One technique is called as NSP. Okay, what is NSP? It is called as next sentence prediction. Okay, there is another technique called as, next sentence prediction and okay, masking. Okay, so like this, there are multiple techniques that can be used. Masking means simply they will stop showing few words to the model, and your model will understand the pattern from the data, and using that pattern it will identify what is the word which is masked, the word that is masked. Okay, so next sentence prediction and masking. So these are the two popular techniques usually that have been used in LLMs. So any LLM can be built any of these methods. So mandatorily what is required? Your transformer is the heart. Transformer with attention mechanism. Okay, transformer with attention mechanism. Okay, so this is how you can understand and interpret a large language model. Right now, there are a lot of large language models. As I mentioned, we have like, simple BERT. You can use something like T5. You can use something like Anthropic models. There are Llama models, right? And even your Copilot. Okay. So like this, there are different things are available now every day. Almost a lot of players are slowly entering into this market. Those who are creating their own LLMs, and there are few LLMs that are specific to the domain. For example, few LLMs are, they are good in understanding the medical related data. Few LLMs have been created only which can be applied used in financial sector. So domain specific LLMs also now they are becoming very popular. Okay, so this is about the story of LLMs. Just let me know, guys, quickly. Yes, no, any doubts so far? Yeah. So quick. Yeah, that is fine. Yeah, I'm coming to that. It is, see, they are mentioned in the train data, Vignesh. It's very simple. Okay. That entire depends upon the train data and the instruction that you are giving. That is fine. Okay, fine. Okay. Now, but practically, you need to understand one thing here. It's okay. Like Tanusri, I'll speak at the end about it. Okay. Yeah. Oh, that's fine. Okay. Yes. You can use, if provided that if you have access, that's not an issue. Right. Okay. Now the question is here, one truth you need to accept it. Okay. You can create, you can create. So I'm like writing it like a notes. Okay. It is like a note. Can you create a machine learning model from the scratch? Yes or no? Can we create machine learning model from the scratch? We can create, right? We can create. What about like a model using ANNs, like deep learning models? Okay. Even you can create, there are few challenges, but still you can create up to some extent. Okay. But if you are planning to create your own LLM, you cannot. Okay. Don't expect that, you can create your own LLM. That is, I can say, highly impossible thing, because you need, first of all, what is the limitation? The data. Data is the biggest limitation. If you say that you will purchase the data from the Google, then simply I will say that what about the computing power? What about that GPUs, TPUs? Okay. So those things are not accessible to you. That's the reason you cannot create your own LLM independently. So that's the reason. Now, what is the trend? The trend is creating, creating, creating customized applications using existing LLMs. Existing LLMs. Okay, we can create a customized applications using existing LLMs. Now, what is a customized application? As per your requirements. Okay, for example, you want to build a resume analyzer, you can build it. So use, as a user, they can upload the resume, and your model will analyze the resume and it will give the result. So you can create an interface for that, and you can like convert it to like an application, right? Similarly, I want to create something like, data analyzer. I will upload my data and my LLM will analyze the data and it will produce the result. Okay, so I can use LLMs and I can create the customized application. And this is what the latest trend. And the people, those who are saying, there are offers like something like, related to generative AI roles. So basically, they are not working on LLMs, creating LLMs. They are actually working on creating the customized applications using LLMs. Okay, so this is what the trend. So now you could be able to use the LLMs properly. In order to use the LLMs, first of all, you need to have the access. Some LLMs are accessible for free of cost. They are open sources, but there is a limitation in terms of number of tokens. If you exceed the number of tokens per day, probably you need to wait until the day is completed. The next day you can start using those LLMs. Okay, or else commercially, if you want to use, you have to take the membership and you have to pay, and so that there is no limitation in number of tokens per day. Okay, so that means you need to pay something for that really. Okay, now I will show you some of the free LLMs, how to use them, how to call them. Okay, one or two LLMs I will try to use, and let's write a code for that, guys. Okay, so that is what we're gonna learn in the upcoming 20-25 minutes. Okay, I hope I am clear. Any questions so far? Everything is clear? Yes, no, quickly. Yeah, quick yes, no, yes, no. See, there are some people, those who are posting some authorized, unauthorized, links. Don't click those links, okay? Yeah. Yeah. I'm coming to that. What is that hallucination and all? We can, okay? Yeah. Yes, definitely. Yeah. Okay. Okay, guys. Now, just quickly, let us see the code, how exactly this code look like and how to, creating this LLMs, how to use the LLMs. Okay. So first, for example, most common models that are accessible for everyone is, Google models, Google Gemini AI models. Okay. Now, if you want to access these models, so you have to create the API key for this Google Gemini AI models. Okay. So how to create the API key? So just go to Google AI Studio. Okay. You can quickly try this. Okay. Don't share your API keys with anyone. But what I suggest you is, you can open Google AI Studio. So you can open directly, go to Google. Okay. So you can do that, Google AI Studio. You can just open it. So enter into Google AI Studio. Okay. So there is an option, right? On the top, you can see the create API key. So please create your API key. Click on create API key and you need to enter the model name. Okay, so just click on API, create API key. It will ask project name. You give some demo, something like that, and click on create API key. Automatically, that API key will be created. And after creating the API key, there is a copy option. Copy that API key. Okay, please all of you create the API key. Once your API key is successfully created, so you can just copy that. I hope my instructions are clear. Please all of you try this. Those who don't know how to create, how to use Google Gemini models, I will show you. Okay, now? So all of you please create this. Yeah. Once again, Akhila, no problem. So just go to Google, just go to Google. Okay. Then just what you can do is you can type Google AI Studio, Google AI Studio. Now you enter in this Google AI Studio. You click on this Google AI Studio. If you click on Google AI Studio, then you can see there is something called as option here. Create API key. If you cannot find option at the top, you can search in the bottom. Somewhere it is on the screen, you will find create your API key. Okay. I hope it is clear. Yeah. So create your API key and copy it. After copying that, save it in a text file. Open a text file on the desktop. Open the text file on the desktop and just save it. Paste it and save it. Save the text file. Okay. All of you, after creating the API key, that's fine, Sanika. After creating the API key, copy it, open a new file in the desktop, text file, paste it and save it. Okay. Once your API key is created and saved, please message me, text me in the chat box stating that API key is created and saved. Okay. So API key is created and saved. So like this, you just give me a message, which is an indication that, now your API key is ready. That's fine, Lochan. Yes, I'll wait, not an issue. Yeah, very good. Yeah, that's great. Now your API key is ready. So now you can make use of that API key and you can we can start using the models, showing the models. Okay. Now all of you open Google Colab. Open Google Colab. Just you can go to simple, you can go to Google. Okay, and just go to Google Colab. Okay, so welcome to Google Colab. Click on this. Okay, after that you will see a new file here, new notebook. Click on the new notebook so that Google Colab will be opened. Okay. Yeah. Create it, Soundarya. No problem. We are not in hurry. Just create it. Okay. Create it. And guys, for your surprise, now we have one more contest today, like yesterday. So I hope really you could be able to get something out of this workshop. Now, before ending of the session, you have to do this task. Okay. You share, you create a LinkedIn post. You create a LinkedIn post. Okay. By sharing your experience. Okay. Sharing your experience in this workshop. Okay. And I'm telling you, in your post, LinkedIn post, mandatorily you must and should tag Innomatics Research Lab. Okay, you tag Innomatics Research Labs. Okay, and you tag me. I'll show you what is my account, Upender Mutyala. You tag me. Okay. Okay, you tag me as well. So mandatorily you have to tag Innomatics Research Lab. Then you share your post. You share your post. Before the end of this session, you have to do this. You share the post. Okay. Now, whomever will be creating most popular post means from today by tomorrow under 24 hours, whomever will be getting the most popularity, that post, the top 3 posts will be getting a surprise gift from Innomatics Research Labs. Okay. So I will show you the LinkedIn, what are the things that you need to tag, and just let me show you guys. Okay, just you write your experience of this today's workshop and just you try to share it. And I'm just trying to show you the LinkedIn. So I'll show you what you need to tag in the post. Okay, so this is what my LinkedIn account. You can tag me. Upender Mutyala is my name. You can tag me. Similarly, you also tag something like Innomatics Research Lab. I'll show you our page. See, Innomatics Research Labs. So you tag Innomatics Research Lab. See, we already have 48K followers. Okay, guys. So you follow our Innomatics Research Lab. You can see every project done by our student will be posted in this LinkedIn, and the student, those who are getting placed, also will be posted in the LinkedIn. You can contact with them. You can have a chit chat with them. Okay. So you need to tag the Innomatics Research Lab and also tag me, guys. Okay. Innomatics Research Lab, you tag in your post at the same time. So this is my LinkedIn of the Innomatics Research Lab and my LinkedIn. You create a post and tag it. Okay. For example, you can see here one of the project done by student, which is like, they are using NLP. And this is how after doing a project, the student has shared his experience. Okay. What are the things that have been used? So in order to complete this machine learning plus NLP, so they have used data collection, data pre-processing. Now this is a text data based, I just now told about bag of words, right? Bag of words technique is used. TF-IDF technique is used. Okay. So like these are the things, and accuracy of the model is around 90.09. Okay. And these are the various tools that have been used in this project, like Python, Pandas, NumPy, Scikit-learn, NLTK, Streamlit, and JobLib. Okay. And you see Innomatics student is right. And you see, this is what live working of the project. Okay. You can see this. Okay. Probably. So this is how it is working, how to apply the input. So they have converted this into application, and it is a deployed model. Like this, there are a lot of models are available, lot of posts are available. So now I'm asking you to create a post to share your experience of this today's discussion, and please tag Innomatics Research Lab. If you don't tag Innomatics Research Lab, we won't consider that post. Okay. Yeah. Take few minutes quickly, then we will run the code. Okay. Okay, Raju Patil, you're asking my name. Okay, I'll show once again. No, you create after getting the certificate also, you can create one more post, no doubt. Yeah. Yes, you'll be getting now. Those who are participated for 2 days, they'll be getting, no doubt about it. Again, I'll share the QR so that you can fill the attendance form, so that you'll be getting the certificates. Yeah. Yeah, definitely. Yeah, you can see this. This is what the LinkedIn. You just share what you have learned. You just share your experience in this 2 days workshop. That's it. Okay. Okay. Done. No. Now that you can do it later. Okay. That's fine. Monisha, that can be done once again. No problem. Yeah. Attendance is not yet taken for today. Wait. I'll share the QR. After executing the code, I'll share the QR. I have to share the notes also, today's notes also, right? I know you're eagerly waiting for the notes. It's okay, Sai Ganesh. We'll connect back. Don't worry. Okay. It's up to you, Dev Sharma. You can add if you want. I'll share once again. See, yesterday's and today's notes, I'll share it like a one PDF file today. Okay. Yes, both day 1, day 2 notes will be shared in one file. Don't worry. Okay. Yeah. Collab also I'll share. Collab file also I'll share. Don't worry. Certificates. Yeah. Professor Suraj, the certificates will be shared through the email IDs. Okay. Whatever the email ID that you are giving in the attendance, to same email ID, you will receive the certificates by Monday. Okay. Yeah. You will be getting it. There is one more question. Yeah, after this session, I'll post this in WhatsApp group also. Don't worry about it, Sindhuja. Yeah. Attendance QR, I'll show you guys. Just wait. No, don't post it in the Jupyter notebook. You just post your API key in a text file and save it. .txt file, right? You just save it. I'll show you what to do further. No, it is better if you can do it now. After getting the certificate also, you can post it. Don't worry. Yeah. Yes. I'll show the attendance QR. And before that, we will try to run the code. I'll show you how to run the code and all. And then we can go to the attendance part and all. Yeah. Now, so first you need to install the Google GenAI. So I hope you're all using like Google Colab. So run this command pip install Google GenAI. Okay. You install it so that your Google GenAI, it will be installed. These tools will be installed. Now, after that, what you need to do? You have to load your text file. Okay, whatever the API key, that file that you have saved now, you upload into Google Colab. So there is a files option here. Okay, then if you click here, it will allow you to upload the file. See, okay, here there is file uploading option is visible. Okay, so you can click here. There is a folder symbol. If you click on this folder symbol, there is upload option. If you click on upload option, then for example, I have stored my files here. Let me say, I can say, see, Gemini API key. This is what my Gemini API key. So this is my text file where I have stored my Google Gemini API key. Now that file will be visible here. Okay. So now you just, after loading it, just write the code like this. Your API key is equal to open Gemini key.text in read mode, and you are reading it. Okay, you upload your API key, then you just create this API key, a variable, assign it to variable. Then you import your Google Gemini AI, then you create a client, GenAI.client. Now, what is requirement? If you want to create a client, you need active API key. So you can create an API key and you can create the client. Okay, right. So I will share this file with you. Don't worry. Okay, so that you can interact with these things. Meanwhile, just let me share the notes also. Yeah, you have to execute, you have to execute. I will show you just, like model code here. If you execute it, it will run it. But my Google Gemini tokens are exhausted already for today. That's the reason I cannot run here. Okay. So, but you can run because just now you created your API key. Now it will run. Okay. Definitely, Ajmal. Yeah. I repeat, yeah. Pradnya, Vikhar, definitely. Together, 2 days notes will be shared as one PDF. Which post will consider? We will consider whatever the post that you will create before the session. Only that will be considered. Okay? Yeah. After getting certificate also, you can create another post. You are welcome. But as this is a context, no? So context should have a limited time frame, right? That is why we are asking you to do it. Okay? Those who have created the LinkedIn post, please share the link in the chat box. Notes directly, I'm sharing a PDF. There is no need to add it in the drive and all. Okay. Yes, yesterday's ML model also I'll share. Okay. Agents, that is little bit, long task. Directly, we cannot create the agents, guys. Okay. Probably if you have another workshop, we will try to cover. That cannot be done within just 2 days. No, tag, you check it. Innomatics Research Lab will be a tag. It can be tagged. Okay, already I've shown the worked example for you. So for example, if you take this post, no, You can see here, right? Innomatics Research Lab. The tag is available here. You can see it is a clickable link. Okay. So that can be done. It's not an issue, I hope. Okay. Right. So now we'll try to share the recorded videos. We can see the Raju Patil has created a post. That's fine. Thank you, Rajiv. Done. Okay. Yeah. So like this, you just try to. Oh, I got even Shiva Nayans also. That's fine. Right. Okay. See, it's very easy, guys. See, your friends are doing it. Now let's go to attendance also. Let's move on attendance. Sarthak. Fine. Innomatics. I think it is. Spelling is wrong. It is Innomatics. INNO. Check it. Check this. You can edit this still. Okay. You can still edit this. Sarthak. Spelling is wrong. INNO. It is Innomatics Research Lab. Then automatically it will come. Okay. Yeah. This is UPENDER, not DRA. Spellings are wrong, just nothing yet. You can see here. Okay. So just edit it, Sarthak. Yeah, that's fine. And now let me try to show you a QR code for your attendance and certificate, guys. Yeah. You can scan this QR and you can scan the QR to get your certificate. Okay. Just try to get this. Scan the QR. Once your QR code is scanned, just let me know, guys. Once your attendance is done, let me know. I can see another LinkedIn, Snehalata, that's fine. The next, yeah, Akshita, that is fine. Attendance link is on the screen. Attendance link is on the screen. It is not working. Just a minute, just a minute, just a minute, just a minute. It will be enabled. Just a minute. Just a minute. Just a minute, just a minute, guys. Attendance, sorry. So just a minute, it is enabled. It will accept the response. Wait for a minute. It will work. Just wait, just wait. Just wait, guys. So meanwhile, let me check another LinkedIn. Yeah, attendance is working. Sarthak, I think it is fine. Right, Mohan, that's fine. Let's see. Yeah, QR code. Yes, you can see this. Now you check. I think it is probably, it is. Sir, done, kada? Okay. Right, sir. Okay, done. Yeah. Okay. It's working. It is accepting the responses. Now you can fill the attendance. No worry. Yeah, it is working. Can you try Poonam again? लिंक, अरे लिंक भी लगा लो, स्कैन करके लिंक भी लगा लो. Chapman. Okay. Yeah. It's working. Yeah, it's working, Swarupa. That's fine. You can take it. All of you. Okay. I'll also try to post the link. Give me a minute so that I can post the link. Uttapalli Sahiti, that's fine. Yeah. Huh. You will get a certificate. I think the link is also posted for the feedback form for attendance. Post multiple times. Okay. Sai Ganesh, don't worry. You just fill today's form. Don't worry about it. Okay, guys. Not feedback. Is it feedback or attendance? Attendance. It's attendance link. Check it. Type it, retype it, and share it multiple times. Please, everyone, I hope filled attendance. Quick. Give me the response. Yes, no, yes, no, yes, no. Okay. Guys, you will receive the certificates by mostly by Monday. If not Monday, you can wait till Tuesday. Okay, because there are more than around 750 participants total. So that's the reason. It is automatic certificate generation will be done, and you will be getting either Monday or Tuesday. Okay, no problem, Dev Sharma. We will consider that. Leave it. Okay. Yeah. Please just confirm me quickly whether you are done with the attendance or not. Yeah. Mm. You consider it. Okay. Sir. Uh, uh, okay. Yeah. Okay. Be careful in filling your email IDs. Whatever the email IDs that you are mentioning, only to that email ID you will get. If that email ID is wrong, then it cannot be. Okay. So please, and try to join the WhatsApp channel for the further communications. If this is done, then we will discuss few more things about the LLMs. Okay. Link again. Link. Yeah, just I am pasting. Okay. So link is posted, guys. Check it. Link is posted for your attendance. WhatsApp channel link is also posted. Please join that. Yeah, notes I'm sharing because few more things to be discussed. That's the reason. Once those things are discussed, I will share the notes. Cola file also I'll share. Don't worry. Yeah, Cola file also I'll share, guys. I hope everyone completed the attendance. I hope I can stop this one. Okay, right. Now let us go to that. Hello, sir. Huh. That's fine. Okay. Yeah, my name is Upender Mutyala. You can see that. Right. Now, next one is let's talk about the code once again quickly. Okay. Now, after creating the client, now you can ask your model to generate the content, right? So now you see client.models.generate content. Now, which model? See, there are multiple models available provided by your Google Gemini AI. So currently I am using Gemini 2.5 Flash. Okay, let me quickly show you these models. Okay, simply you can go to the Google. You can go to the Google. Okay, you can type Google Gemini AI models. Okay, you type it. So it will show you the Google Gemini APIs and the models. I'll show you what are the current models that are active. You can see the latest version is Gemini 3, Gemini 3.1 Pro, Gemini 3.5 Flash, Gemini 3 Flash. Okay, similarly Gemini 3.1 Flash Lite and Nano Banana 2, Nano Banana Pro. Okay, then Gemini 3.5 Live Translate, Gemini 3.1 Flash Live. Okay, these are all the various models, right? Now, just one in my program, I have used Gemini 2.5 Flash. Okay, if I open this, if I click on this, it will open. Now, what is my model name? The model name is this Gemini 2.5 Flash. You see, in my code, I have written the same. So, if you write in different way, it will not execute. Same model name you have to mention, guys. Same model name you are supposed to mention. Otherwise, it cannot be executed. Okay. So here, now you can see what type of inputs it will accept. You can enter the text data. You can enter the image data. You can enter video and you can enter means this Gemini 2.5 Flash model, it will accept the input in the form of a text, image and video and audio. Okay. But what type of output? Output will be only text. You can enter text as your input, image as your input, video as your input, audio as your input. But what type of output will be generated? Only the output will be given in the form of a text data. So this is a text generation model basically. Gemini 2.5 flashes, only it could be able to generate the text. Okay. Now what is the input token limit? Maximum you can enter this many number of input tokens and your maximum output tokens can be 65,536 for this free edition. It does not support audio generation. Okay. So like this, you can check the properties of these models. Okay. So when this model was last updated, it was updated in the June 2025. Okay. Now, similarly, if I go back, if I check the latest model 3 version, if I check the Gemini 3.5 Flash, if I click on this, now you see this. This is the code of the model Gemini 3.5 Flash and input will be again text, image, video, audio, and you can enter even PDF. So this Gemini 3.5 Flash can take PDF document as an input and finally it can give you output in the form of a text only and token limit is not changed, it is same and other audio it doesn't supports, right? Similarly, if I show you 3.1 Pro, now you see this again, this understands about text, images, video, audio, PDF, and finally it can token limit is almost same. So there are few changes you need to, some features are not supported. So you need to carefully study this document in order to understand, in order to use which model is most suitable in order to perform the task. Okay, so like that, now Gemini 2.5 Flash is completely free. That's the reason I'm using this. Sometimes they does not allow you to use the latest models. That is why I didn't use Gemini 3.5 versions. Instead of that, I am using Gemini 2.5 Flash. Now, this content is nothing but your question. What is the question I am asking? Who is Indian president? Okay. Now, if I check the response, it is given me that the current president of India is Draupadi Murmu. Okay. So like this, your your Google Gemini AI model is giving you a response. Okay. Here, I didn't use Google Gemini AI application directly. Instead of that, I'm calling the LLM. Now, what is my LLM? This is my LLM. Gemini 2.5 Flash is my LLM. I'm creating API key. Through API key, I'm just calling the model. With that model, I'm interacting. Okay, if I could be able to convert this into an application with the help of Streamlit and all, then I can create an interface. Now directly user can enter a prompt and your model will give a response. That's how we can convert this entire thing into a single application. Okay, just now I have seen one of the model created by our student, Innomatic student. You can check it, right? Similarly, okay. Anyway, I'll share this file with you so that you can directly execute. But make sure you have to use your own API key. My API key will not work for you. Okay, I'm sharing this in this. Okay, so I'm sharing the text, this file, code file. You can check it. The code file I have shared here. You can download it. It is .apynb file. Okay, but you need to, in order to run that file, what is needed? You have to substitute your own API key. Okay, it does not run with my API key because my API key you cannot access. Okay, guys. Now just let me share today's notes also. Today's and yesterday's notes together. I'm sharing it. Now just I'm printing this. Let me print it. Okay. So Innomatics workshop notes. Okay. I'll say full notes. So whatever the notes that I'm creating, I'm just sharing it with you here. So happily you can use this. Yeah, so let me share the notes also here. Now this is the full notes. Okay, now it is approximately 8 MB, 7.5 MB. See, now you are in the chart, you can directly download it, right? I have already shared the notes. The name of the file is Innomatics Workshop Full Notes. You can download it. Okay, please. The code file is also already I have shared. Yeah. Okay. Now let me go back to the file and let's have a discussion. Now, if I want to make a multiple conversations, okay, then instead of using the client, okay, I can use another method called charts.create. I can use another method called as charts.create. Here, what is the method I've used? Models.generate content, right? Now let me make another request like using, so for same client I'm using, and now what I'm using, charts.create. I'm creating a model, then directly I'm sending a message so that I can send multiple message. For example, here I've given who is the father of computer science. Okay. Now, if I show the response, the individual most widely recognized as the father of theoretical computer science and artificial intelligence. Okay, then just let me show the output fully. You can see this Alan Turing, right? It is given about the Alan Turing. It is talking about that. Now, similarly, tell me a powerful info about generative AI. Another chart I have passed. Now, this is what, this is what the response that I have received. Okay, so like this, you can interact with your LLM. Okay, you can give any prompt and directly you can interact with your any model, right? Here specifically, I'm using what? Gemini 2.5 Flash version. So this is how you can interact with your own LLMs. Now you can use these LLMs in order to, you can create the front end for this. You can link up the same code with at the back end so that that will become an application. And as per your requirements, you can customize it. So what type of input you need to ask, what could be the length of input and all. So these things can be easily created. Okay. Yeah. Yeah, definitely. I'll upload the PDF again. Yeah, definitely. I once again, I'm just trying to share my notes. Yeah, workshop, full API notes, and along with the code file I'm sharing. So this is shared. Okay, both I'm sharing, just you can download it again. Okay. So if you are looking for any counseling, like if you are interested, like any of the course, any of our courses, just you can contact the numbers, these numbers, guys. So this is the number like Hyderabad Center. The number is posted. Okay. You can download it in your phone, no doubt. Just click it, it will be downloaded, but it cannot be opened. It cannot be opened. Okay. Just for your information, like because you might be having little, things about the course. And one thing is like Innomatics Research Lab are conducting the courses. We are popular in conducting data science and generative AI. India's top one edutech it is data science okay, and artificial intelligence. And another one is we are also running like, full stack development course. Okay. Now all types of courses will be conducting in both the online and offline modes. Okay. Online is available. Exclusive offline is also available. Okay. And if you say the timings, so the first batch timings are like 9 a.m. to 11 a.m. in the morning. This is offline and online. Means you can join these sessions in offline or in online. Okay, guys. So this is one. Now, second thing is at second session starts with at 11:30 a.m. to 1:30 p.m. This is also like offline and online. Okay. Now there are exclusive onlines like 7 a.m. to 9 a.m. If you are a working professional, okay, then probably you don't have time in the day. So then you can utilize this 7 a.m. to 9 a.m. These are exclusively online batches. Okay. And there is one more online batch, which is from 8:30 p.m. to 10:30 p.m. If you're an ongoing student throughout the day, you are busy with your college and other works, then you can choose this slot 8:30 p.m. to 10:30 p.m. and you can learn the generative AI and related things. And this is also fully online batches. Okay. So for further more details and all, you can please contact to the numbers that I have given. Okay. Yeah. Registration form link. Can you post it again, the link? Yes. Yeah. Okay. Right. Definitely. See, no one will give you service for free of cost. You cannot expect everything for free of cost. Okay. And after learning everything, you are expecting salary, right? Are you working for free? Are you ready to work for free? No one, right? So that is not the right question. Okay. Definitely courses are paid courses. They are like, 6 months long courses with fully certified courses. To know more details about it, we are provided the contact numbers. Please call to them, those numbers. Okay. You can approach those numbers. Okay. So that our counselors will have a chat. You can have a discussion with counselors. You want me to share once again? Okay. So I can share it, my notes once again. Yeah, code file and the notes. Once again, I'm sharing it in the chat. Yeah, any questions, any doubts, let me know, guys. Shravani, I'm coming to you. Yeah, yes, live classes. They are not recorded. Sharvari, it is a live classes. All are live classes. Online, offline, both are live classes. Okay, yeah, that's great. Yeah, you just contact for fee and all. You just contact Sangeeta. Contact details are available in the chat box. Please, you can contact. Not certificate link, you will receive the certificate to your email. You will receive the certificate your email to whichever the email ID that you have provided during the registration or during this attendance. Okay. No, it can be downloaded, but it cannot be opened. If not, you just go through with the, I can say, computer. Okay. Have shared from my side. Now it is downloadable. You can download it. Okay. Sania, you're asking for my LinkedIn profile. I can show it like, this is what my LinkedIn profile. Okay, just a minute. Let me open this. So this is what my LinkedIn profile. Upendar Mutala. You have to also tag Innomatics Research Lab. Don't forget that. You should also tag Innomatics Research Labs. Okay. And follow the Innomatics Research Lab so that you'll be getting a lot of things. All the projects that are done by our students will be available in this Innomatics Research Lab page. The placements that are happened. Okay. See like this candidate is placed in Win4 Solutions. Okay. And another candidate like, Sai Charan placed in Prolifics as a business analyst. another candidate like Sri Lekha placed in business as in Prolifix. So like that, you will be getting a lot of updates in this LinkedIn. Okay. So try to tag this Innomatics Research Labs in the post. And after getting the certificate also, you can create the post, guys. Yeah. Code file, I shared it already, Debabrit. Okay. Depratim, I have shared it already, code file also. But anyway, once again, I can share it. This is what the code file. Yeah, it's fine. Shraddha, you're asking, no, you will just get it to your email certificate. You don't need to do anything for that. Okay. You will get it to a simple. Okay. Just, I hope you have filled the attendance form. If you have filled the attendance form, you will receive the certificate. Okay. Yeah, that's fine. Yeah. Definitely. Okay. I cannot do it now, right now, Dev Sharma. Just I can do it after the session. I'm in session right now, right? Okay. Yeah. Yeah. For everything, internship opportunities and all, you just call us the numbers. Please call us so that we can help you with further information. I cannot give you entire information within the session. Okay. Please call us regarding internships and training programs and all. You just call us. Okay. Yes. Please call us. Reach out. We have given the contact numbers regarding the price and all. Please contact us. You want me to share once again attendance link? Deepesh, can you put attendance link? Make it. Yeah, it's almost it's done. Yes. Almost it is done. Yeah, attendance form is posted again. You can fill the attendance form. Yesterday's code also I can share. Give me a minute so that I can share yesterday's code also. That's not an issue. Uh, yeah, I'm sharing the yesterday code also. Give me a minute so that I can share that code. Yeah, I'm sharing it. Yesterday code file. Yeah, the code file is shared. Yesterday code file also. Banana quality prediction model. Shiva Nayan, contact details are again posted in the chat box. You can see that. Ishwar, can you post the contact details once again? Yeah. Thank you, Avishkar. Contact details are available in the chart. Let me post it again. Right. Yeah. So just you can reach us. You can reach us to these things. Yeah. Thank you. Yeah. Okay. So thank you for your cooperation and all, for your patience. Now, one question, one student asked about hallucination. So hallucination is nothing but, usually models will interpret, okay, without verifying the facts, they will understand the question, the prompt, and they will give you some random answer. Sometimes your response will be correct. Sometimes the response will not be correct. Okay. For example, if I ask the question like, who received Nobel Prize in, let me say, 1850. Okay, definitely it will give some answer. But to be specific, in 1850, there was Nobel Prize is not available. First time the Nobel Prize was created in the year 1901, something like that. But without verifying the facts, so it is generating the response. So such type of thing is called as a hallucination. Now, in order to overcome that, you need to introduce the memory concept. Okay. So in order to introduce the memory, you should be familiar with a library called as a lang chain so that that problem can be overcome up to some extent. Okay. That is not the final solution, but that's the primary solution. And the biggest challenge with this LLMs is, the biggest challenge is these models will keep on changing, right? Just now I've shown you the latest version is 3.5, previous version is 2.5, prior to that 1.5. Okay, these versions keep on changes. So every time the version is upgraded, you need to take the new subscription and you need to work on these in order to enjoy the latest features. Okay. And you should be careful in giving the prompts. Much more accurate prompts need to be given. Okay. So thank you for everyone. Yeah. So just share the overall feedback out of 10, guys, before you leave. Out of 10, quickly share your feedback out of 10. So I hope definitely I have given some good information. So whatever, okay. So let's just try to provide your feedback. That's fine. Thank you. All right. Okay. Yeah. Any questions specifically? Now I am open to take the questions. If you have any questions, you can directly ask or you can put it in the chat. Okay. Yesterday showed code file, another one once again. Definitely, I'm sharing once again the code files and the notes. Don't worry, that is not an issue. Code files and the notes I'm sharing. All the two code files and along with the notes, I'm sharing it again. So please, okay. Attendance form is available in the chat. Please check it. Attendance form is available. Check it. Okay. Yeah. It is available in the chat. Please check it and fill it, guys. Thank you. Thank you, Praveen Verma. Thank you, Rani Reddy. What is the difference between transformer and LLM? Okay. See, LLM is a trained model. Transformer is a component of your LLM. If you want to create an LLM, you need a transformer, right? That is the difference. Now, it's okay, Anshul. I'll take care about it. Don't worry. We'll take care. Our team will take care. Definitely. But right now you are in the meeting. You can download on spot. Why you are expecting me to share it in the WhatsApp? It's okay, Anshul. It's okay. This content cannot be viewed here. What regarding what? Regarding what are you asking? May I know? So yeah, code file I have already shared. All the notes, everything I have shared. Definitely. Attendance link, we already shared it. See, someone is sharing the links which are external. Okay, don't fall in their traps. Yeah. They are downloadable, man. If you want, I can share individually again. Not an issue. So you can see full notes. Once again, I'm sharing it. Okay. Yeah. Yes, that is what, na? That it also depends upon the system architecture and everything, right? So how your data is being transmitted. There are a lot of factors. That is what you need to learn a lot. Okay. There are parameters for every model and how you are adjusting that parameters. If you change the parameters, definitely the output will be different. And that is the biggest problem with LLMs, right? Consistency. You will not get your output is not consistent. Same question, if you ask multiple times, it will give different responses. Okay. Just I shared the notes again, just have shared it. Okay. Just maybe 30 seconds ago, I've shared the notes. This is what, okay. Inomatics workshop notes at 7:28 p.m. You can check it. Okay. Yeah. Rani, I have already shared the, attendance. If you want, you can quickly take it. You're asking me for attendance QR. I can show it once again. Just check it. Okay. So those who doesn't fill the attendance form, just I'm sharing the QR. Please go through with this. Quickly scan it. I cannot wait more than a minute. Okay. Yeah. Okay, now you can see, I hope you can see my screen and just try to, okay, complete the formalities. Hmm. Yeah. Attendance QR link is also posted by Vamshi Krishna sir. Okay, just go through with that, guys. Definitely, Namita. That's fine. After this, we'll do it. Attendance form is available here. Right, guys. Yeah, any questions? So before I wind up, any questions, let me know. If you need any assistance in the training related to data science and generative AI or full stack, you can contact us anytime. If you are you're like near to Hyderabad, you can approach the Hyderabad centers. If you are in Karnataka, you can approach the Bangalore center. If you are in Maharashtra, you can approach the Pune center. The others, you can contact us directly. Okay. Fine tuning is, adjusting the parameters. Tuning is nothing but adjusting the parameters. Every model will have a lot of parameters. So that is nothing but adjusting the parameters. Why you need to adjust? In order to get the required response, right? That is what fine tuning. But fine tuning is, it is not much preferred method, because if you tune your model and after few days, model changes, then what you have to do? Again, you need to retune your models, right? So that is why fine tuning is not the permanent solution. Okay. Yeah. Yeah. Any questions, guys? Any questions? Let me know. Please, yeah, Anshul, tell me what's your question. You can ask, you can mention the question. Just now explained, hallucination means without verifying the facts related to the question, information related to the question, your model will respond. This problem is called as hallucination. Okay. Whether we are asking exact thing or not, okay, then that is called as a hallucination. So in order to overcome that problem, you need to, verify each and every fact. Okay. So means that requires a memory component. So if you want to add the memory component, you should be familiar with the LangChain library. Okay. Can you unmute me so that questions regarding AI and present scenario AI? You can put it here, Abhinandan. You can put it here. You can just type your question so that I can answer. That's not an issue. See, a lot of people are, how LLMs can be. See, it's all depends upon the trust, right? How accurately you are, getting the responses from the LLMs. That is very important. So, like, that's the reason. So it's all depends upon how effectively you're customizing. In order to customize that, you could be able to validate the output, you could be able to tune them, you could be able to optimize your prompt, right? That is called as a context optimization. So you have to be good in this. Okay. Abhinandan, yeah, I think you can, right? You can unmute and speak. You can unmute and speak. That's not an issue. Yeah, you can unmute and speak, Abhinandan. I think there is unmute option because it has to identify pattern, no? So if you give, for example, just if I give one paragraph, how much amount of data it can understand, right? So if there is much data, much more patterns, because language has a lot of patterns, hidden patterns, right? If every pattern it has to capture means it should be like, needs a lot of data. That's a simple question. Yeah. You can type it. Abhinandan, I can wait. Okay. You can type it. Probably it is disabled by the host. It's fine. But still you can type it just. Yeah. Any questions? Last call, guys. If you don't have further questions, you can leave the meeting. Yeah, you can leave. If there are no questions, you can leave. If any specific questions, you can stay in the meeting. Yeah, retrieval augmentation generation you're asking about. Like it's one of the solution that the problem that you have asked for, like, hallucination, right? So now retrieval will fetch the information, augmentation will process that, then accordingly, your model will respond, generate the response. Okay. So RAG in short, that is the solution, one of the solution in order to overcome the hallucination problem. No, hallucination, it depends on, no, we cannot say poor training might be the reason, but it is like, data, issue with the data, right? Facts. If the enough information is not available, then that is a problem, right? Yeah. Because there is no source, right? That's the reason, Anshul. There is no source. That's the reason. Yeah. Fine. Yeah. Your course certificate mostly you will be getting by, in the worst case, by Wednesday. In the worst case, by Wednesday. Okay. No worries about it. If you have filled the form, you can be happy. You will be getting, just you keep on observing your email. That's it. Okay. Whatever the email that you have mentioned in your attendance form, to the same, you will be receiving it. Yeah, that's fine. Okay, guys, the last call. If you have any attendance form link, already we shared it. Uh, Once again, if you want, I'll try to share the attendance form link. Why you didn't fill till this time? Okay, so yeah, this is the attendance link. Once again, I've shared it. Quick, guys, quick. Yeah, which test you're talking about? Shared 10 times so far. Notes, yesterday's and today's. Okay, as you're asking, I can share it again. Try to download it at least this time. Yeah, Abhinandan, you're asking about how IT companies are expecting as a AI employee to get hired in job, right? Because it's all about utilizing the model. So being an employee of the company, you should be able to use AI tools effectively so that, for example, everyone knows, right? If you ask for a ChatGPT, it can give the code. Now, what kind of code? Production level ready code. So what are the limitations? What are the structure? Everything in detail, you could be able to interact with the LLM, right? I'm not sharing anything. It should be able to interact with, right? So if you really need such kind of working code, then you should know effective prompting. Okay, so for that, you should understand what is prompt engineering, what are the types of prompts. So this is what, things that are required. Okay, so that's the reason IT companies are expecting nowadays everyone could be able to know something about AI so that they can easily effectively interact with LLMs so that their productivity can be increased. Okay, Abhinandan? Yeah. Yesterday attendance already taken. Okay, I think you are not there. I cannot do anything for that. Next. It's okay. So thank you guys. Thank you all for spending your valuable time and for your active participation. Okay, please follow us in WhatsApp, follow us in our LinkedIn page. Okay, stay connected so that you can participate in all our future events. And those who are really interested in getting some, good job and good skill set, if you want to upgrade your skill set, then definitely Innomatics is the right place for upskilling. Okay. It can be upskilling or reskilling. We are like, the one of the topmost edtech companies in the entire India. Thank you very much. Yeah. You just leave it to us. Okay. Thank you. Thank you all. So thank you. I think I can wind up. The last call. Any question? Any more questions? Yeah. Thank you. Thank you guys. Yeah. Those who are done, they can leave. Thank you. Thank you everyone. Attendance link. Yeah. Again, I have posted. Thank you, Harshita. That's fine. I'll check it out. Don't worry. You have tagged me. I'll check it out. Rani, as we said, 2 days attendance is mandatory. If you are absent for yesterday's session, I think we cannot. Okay. That setting is not with me, Abhinandan. You can put it your question in the chat. It doesn't take much time to put it. Okay. It's fine. If you are attended, that's fine. We'll mark that chat and we will issue. That's not an issue. Okay. All right. Okay, guys. Thank you. Have a nice time. Thank you for participating. Okay. Thank you. Yeah. Bye bye. I'm winding up the meeting. It's okay, Sulabh. It's okay. That's fine. That's fine. Okay. Thank you. Yeah. It's okay. It's okay, Abhinandan. Fine. Okay. Thank you. Have a nice time. Yes, please. Quick, quick, quick. Anshul, quick. Quick, quick, quick. Definitely, definitely. After this session, okay? After this session, I cannot check immediately. That's the reason. After this, I'll check my LinkedIn and I'll update you. Okay? Yeah. It's okay. It's okay. Sai Ganesh. We'll check. We'll check. There is no session tomorrow. It's today is the last day. Okay, fine. Thank you, guys. Yeah, you can leave the meeting. So thank you. It's okay. No, attendance, it's fine. It's fine. We'll take care. Those who could not be able to mark your attendance yesterday, we'll take care. Okay? Yeah. Thank you. So all the very best for your futures, right? Bye bye.